What's going on, everyone, and welcome to episode 3 of Everyday Python Projects. And today we're going to learn how to speed read. It's the digital age, so we're reading a lot more on a screen than we are in physical books. So it only makes sense to practice on a screen so that we're prepared for the real deal. This program is going to require 3 techniques, 2 of which come from the book Speed Reading with the Right Brain. Technique number 1 is called chunking. This is where you read multiple words at once by extracting the idea from a group of words, rather than traditional reading where we read, one word at a time. The foundation of speed reading is speed comprehension, and that's what chunking allows you to practice. Technique 2. You have to learn how to imagine what you're reading, just like watching a movie. This takes a little longer to master, but you'll end up remembering more because you're associating more senses with the material. Technique number 3. We're going to alternate colors for each chunk when we print it out to the console so that you guys get more practice learning to read chunk by chunk. This will also give you more practice with imagining the material, so you'll build up a great foundation before we move on to faster speeds. Alright, let's do it. Alright, in order to get this started, we're going to have to import a few libraries. So we have Time, Wikipedia, Wikipedia API, NumPy, and Term Color. So why are we using the Wikipedia library? Basically, we can get instant access to millions of different articles that can help us get better at speed reading, and this will be a lot easier doing it this way rather than searching the web for random passages of text and then placing them in an assortment of text files. So we'll need to define 2 variables right away, the speed at which we want the words to print on the screen, as well as the number of words per chunk. So let's write a comment, increase to go faster, speed equals 4, and increase to have more words show up per line. We'll call this num words and also set this equal to 4. And then finally we'll have our search material. And for now, let's call this search material and set it equal to cats. So having a speed of 4 might sound pretty arbitrary, but it'll make more sense as we proceed with the rest of the code. Next, we need to set ourselves up to access the data from the Wikipedia API library. So let's write a comment, initialize the API for your language. We'll call this WikiReader. This will be Wikipedia API dot Wikipedia. And I'm putting EN for English. If you speak a different language or prefer to read in a language other than English, this is where you would change the language based on your language code. And finally, we need to see if the page actually exists. Here we're looking for cats. It's entirely possible that article might not exist. So we need to be able to check for that first before we proceed with the rest of the script. So we'll call this search page, and this is going to be equal to WikiReader, which we defined earlier, dot page, and we're going to pass in search material. And then page status is going to be search page dot exists, and this will just tell us whether or not the page exists. If page status is equal to false, as this will return a boolean, either true or false, print page does not exist. So now if the page does exist, we need to get all the words on the page and then prepare the chunking process. Else if page status is equal to true, we're going to create a variable called word list, and this is going to be equal to search page dot text dot split. So it's going to take the material, in this case it'll be from an article about cats. It's going to take the text and then split it up word by word, and we're going to create a second variable called color or not. This is going to be an input with the prompt, do you want to read this in colored blocks, yes or no? And we're going to transform this into uppercase. Next, we're going to create a list called choices, and it's going to have 2 elements in it, yes and no. While color or not in choices, print please select either yes or no. All right, let's change this to y or n. And then we're going to copy and paste color or not so that the user has the opportunity to input something else in case they put in anything other than yes or no. All right, next we're going to create a NumPy array called chunklocks, or chunklocks, depending on how you say it. It's going to be np.arrange. It's np because we imported NumPy as np. np arrange, and we're going to start from 0 up to the length of the words, the length of the number of words, and then we're going to split it up step by step by the number of words that we specified up top. 2 more lines of code. We're going to create a variable called word color tracker. Set this equal to 0, and then our word color will be cyan, which is actually what it kind of looks like, this color right here. So let's summarize what we just wrote. The while loop will prevent the program from breaking if the user inputs anything other than y or n. Next, chunklocks finds the index of every 4th word in the word list. Y4, that's because we set num words over here equal to 4. If we wanted a chunk size of 3, then we just set this equal to 3 like so. The variable color or not is exactly as it sounds. It gives you the option to color each chunk so that you can easily separate one group of words from the other. Now, regardless of your option to color the words, word color tracker is set to 0 and word color is set to cyan in the event that we run this program again and decide that we do actually want to color the chunks. All right, the gist of what we're going to do next goes like this. We're going to take the entire set of text from the Wikipedia article. We're going to break that into chunks according to the size we set for the variable num words. Then we're going to alternate the color of each chunk. Finally, we'll print that out to the screen. If you said that you didn't want to color each chunk, that'll also be accounted for. To do this, we need to write a for loop that goes through the indices of each chunk. So we can write for x in range length chunklocks -1. Speed read text is going to be equal to word list, and then chunklocks element up to chunklocks x plus 1. Then chunk is going to be equal to join, and we're creating a list here, string lm for lm in speed read text. So this is just list comprehension. Basically, for each element within speed read text right here, we're going to convert it to a string and then join it together into this variable we have called chunk. So in case you guys want to see, what this looks like, this is our entire word list. And if we look at the beginning of word list, say look at the first 5 elements, we see the cat felis catus is. So let's take this speed read text and go from the first element to the second, and we can see that speed read text is the cat felis catus. Remember, we're doing it by groups of 4, and we can see here it is indeed grabbing it by groups of 4. Once we have that, chunk is basically going to take this and print it out like so. That way it'll look much more natural reading it like this instead of, a list with each individual element. Next, we're going to account for colored chunks. So within this for loop, we're going to write an if statement. If color or not is equal to y, then if word color tracker is equal to 0, print chunk and end equals space like this. What this is going to do is it's going to be printing out the words on the same line instead of printing it line by line. Then we're going to set word color tracker equal to 1. Now let's say if word color tracker wasn't 0, let's say if it was actually equal to 1 when we entered into this loop, then we're going to say else if word color tracker equals 1, print colored chunk word color, and word color is what we define here as cyan. And again, we're going to be printing that on the same line. Then we're going to set word color tracker equal to 0, and this loop will be done. Now, let's say you chose not to have the word chunks colored, else if color or not is equal to n, just print out the chunk, and we'll print them all out on the same line. Then we're going to write time.sleep, and this is going to be equal to speed raised to the negative first power. So if you decide to color each chunk, it's going to see if the chunk that's going to be printed out to the console should in fact be colored. That's what word color tracker is for. So we set it to 0 earlier, and here we see if it's equal to 0, then we're just printing the text to the console. However, after we do this, we'll set word color tracker equal to 1. Now, the next time it goes through the next chunk of words, the code will execute this else if statement, where word color tracker is equal to 1. Then it'll print out the word chunk in whatever color you specified for the variable word color, and it'll set word color tracker equal to 0 after this, and the cycle repeats itself. Like I said earlier, time.sleep is there to adjust the speed at which the words print out to the console, and since speed is being raised to the negative first power here, increasing the value of speed means that the speed raised to the negative first power will decrease. Thus, the program will sleep for a smaller amount of time in between word chunks, causing the words to be displayed at a faster speed. Alright guys, great job so far. We're almost done. Just a couple points left to address. When we separated the list into groups of 4, it's possible that we'll have a tail at the end that won't be included in the list chunk locks. For example, if you were to take numbers 1 through 10, split them up into groups of 4, you would have groups 1, 2, 3, and 4, 5, 6, 7, and 8, and then a tail of 9 and 10 at the end that won't be in any group. We don't want to miss out on any text, so we need to account for this and print out a tail in the event that we have one. Alright, how do we check for a tail? It's pretty easy. Once you get out of this for loop, let's write a comment printing the tail, and if length word list is greater than chunk locks minus 1, and let's get rid of that colon there. So if the total length of our word list is longer than the location of the last chunk, then we have a tail. Now, if that's true, we're going to follow the same approach to printing out the words to the console. So we can write end content is equal to word list chunk locks -1 up to length of the word list. So we're going from the last chunk all the way up to the end of the word list, so to get that tail. And the actual tail is going to be .join, and we're going to use list comprehension once again. String lm for lm in end content. Like so, if color or not is equal to yes, and if word color tracker is equal to 0, print tail else print colored tail word color, and we want to print this on the same line. Now let's say we chose not to have it be colored. Elif color or not is equal to n, then just print the tail on the same line. And it looks like there's an error somewhere here. Let's see. Oh, this should have 2 equal signs. Lastly, let's complete this if statement way up top over here by writing our last else statement. Else print Schrodinger's page existence is neither true nor false. So this will never happen, but that's what makes programming great. Programming is perceived to a lot of people as being really boring. I think they just have this idea of a programmer from the 1980s just on loop in their head. But clearly, you can see how many interesting projects you can create in very little time with barely any code. Oh, and if something's really good and a lot of people find a ton of value out of it, you can make a lot of money out of it. Like a lot. A lot. One quick thing I forgot to mention. This right here should have a space, chunk equals space.join, as well as here. If we didn't do that, then all the words would basically be jumbled together without any spaces, which would make it just impossible to read. All right, moment of truth. Let's test this out. I'm going to search Wikipedia for an article on cats. And I do want each of the chunks to be colored. All right, nice. The text is colored and it's separated by chunks. But you can see in my IDE, which is Spider, with my current theme, it's kind of hard to read this. Now, I don't want to change my theme around just for one script. I think that's just a lot of work. So here is one workaround. What we can do is we can import the library sys. And under each of these print statements, we can write sys.stdout.flush. And we're going to put that under each print statement. So have one there, have one here, have one here. So what we can do is we can now run this in a terminal. And when you print statements on the terminal, if you don't have the sys.stdout.flush, the terminal wants to gather all of the data first and then print it out. But adding this allows us to print out each statement line by line so that we can read it like we read it over here. But it'll be easier to look at in a terminal because the colors will be much brighter. So I have a terminal already set up. If we save this and then open up the terminal, we can write python speedreading.py. And do you want to read this in colored blocks, yes or no? Let's type yes. And you can see here, this is a lot easier to read. And if we were to change this to red or bright green, it would be a lot easier reading this here than we could reading it over here. Congrats, you guys now have the tools to be a speed comprehender, not just a speed reader. Thanks for joining me in episode number 3 of Everyday Python Projects. If this video helped you out, please drop a like below and make sure to subscribe to my channel. I make videos like this 5 days a week. Tune in tomorrow for another Python project, and I'll see you then. This will also get you used to